Good evening everyone. Today I will be presenting a review of the metallurgical properties of MgO bearing pellets and their influence on blast furnace slag. This study explores how MgO impact pellet performance and slag behavior in industrial applications, providing insights into optimizing blast furnace operations also. Now let's begin with the metallurgical properties focusing on compressive strength and oxidation in duration. Compressive strength is critical to ensure pellets withstand transportation and furnace conditions without breaking. The addition of MgO, however, tend to reduce compressive strength, which is very important. This occurs due to increased porosity and the formation of magnesium magnetite. So that compound is magnesium magnetite, which sole responsible for increased porosity also. And these magnesium magnetite solid solution which hinders hematite recrystallization. To mitigate these, higher roasting temperature around 1523 Kelvin and maintaining MgO levels below 2.5%. So two most important thing is there, the roasting temperature 1523 Kelvin and maintaining MgO levels below 2.5% are effective strategies to preserve pellet strength. Moving to reduction swelling behavior. This slide highlights how MgO bearing pellets respond during the reduction process in blast furnace, which is also very important. Swelling can affect furnace stability, as we know, and that's why the pellets undergo a swelling test before getting charged into blast furnaces. Apart from these, its understanding the behavior is key to optimizing pellet composition for efficient operation. Next we will discuss reducibility. MgO enhance pellet reducibility by increasing porosity, which facilitates better gas flow through the pellet structure. Research indicates that an optimal MgO content of approximately 1 mass percent maximizes reducibility, improving the efficiency of the reduction process in blast furnace. This slides provides additional context for our discussion, reinforcing the key points about MgO's role in pellet performance. Here we will continue to build our own understanding of MgO bearing pellets and their metallurgical impacts. So as you can see, the all important information is being displayed on the slide, and thus almost all information is available here. For any further information, you may contact my mail. This slide emphasizes the ongoing research and consideration in this field. So I will ensure we focus on core finding as we wrap up. In conclusion, MgO bearing pellet plays a significant role in blast furnace operations, and blast furnace operations people also should aware about this implication of MgO on their pellets. While MgO can reduce compressive strength due to increased porosity and solid solution formation, careful control of MgO content around 1 mass percent and higher roasting temperature can optimize pellet performance, enhance reducibility, and managed swelling behavior further contribute to efficient furnace operation. These findings provide valuable guidance for improving pellet design and slag management in industrial application. Thank you for your attention. Thank you.